In this chapter, we cover probability distributions as the name indicates that involves discrete type of data. And there are three popular distributions that we are going to go through. The first one is binomial, and then we have Poisson, and third one is hypergeometric distribution. So I'll start with the basic definition of what is called a random variable. So a random variable is a numerical description of an outcome of an experiment. An experiment could be anything. It could be, let's say, tossing a coin. So the outcome could be head or tail, or somebody may collect data on number of students who are absent in a class. So generally we represent a random variable by capital alphabets like x, y, z. So let's say we define x as number of students absent in a class. So this number could vary randomly, like it could be 0, none of the students are absent, or it could be 1, 2. So it can vary randomly, that's why it is called random variable. So let's take one example of a coin, and we consider like two tosses. If we have to list down outcomes of this experiment, so it could be head and tail. First one is head, second is tail, or it could be tail head, or it could be both of them are head, and fourth one is both could be tails. In this situation, we can define a random variable x as number of heads on two tosses. So now if I have to list down all possible outcomes and then the related values of x, so this small table is going to look like this. Random variable x is number of heads on two tosses. So in the first case, x will take a value of 1, second case also 1, and then you have 2, and then you have 0. Total number for the x column is 4. Now this information can also be represented in a different format, like I can list down what values x takes. So you can see in this column you have values like 0, 1 and 2. So I can say 0, 1 and 2. And then we can create a column for frequency. So how often we got 0? It was once. How often we got 1? It was 2 times. And this is 1 time. So total frequency is 4. Now based on this we can create f of x, which is the probability or chance of an event occurring. So from this, for the first row, we can find out what is the chance that x takes value 0. So that will be 1 divided by, so this 1 comes from the frequency and divided by this total, which is 4. So 0.25. Similarly, 2 divided by 4 is 0.50. Again, 1 divided by 4 is 0.25, and the total is 1. There are two rules. So for any table to be a probability distribution table or a valid probability distribution table, first rule is that each of the probability values like f of x should be greater than or equal to 0. And rule 2 is if you add all the fx values, it should add up to 1. So you can see each of the fx values like 0.25, 0.50, 0.25. So first rule is okay. And similarly, the total here you have is 1. So second rule also is valid. So that means this table can be called valid probability distribution table. It is called probability distribution table because it shows you how the probabilities are distributed across different values of x. So this is called probability distribution table. So let's say we have data something like this. Now to calculate mean, we have to multiply these two columns. So x times f of x. So in this column, once we add, this number is going to be mean or average, or another name for this is expected value. So mean, average or expected value all are named for the same thing, and that you can get by multiplying those two columns and adding them. So for example, if you multiply 20 times 0.2, you get 4. 25 times 0.15, and so on. and once you add this you get 29.25, which is the average, and we represent expected value or the average by x bar. Now to get a variance, we create a column like x minus x bar whole square times f of x, and then we add that column to get what is called variance. And once you have variance, you can calculate standard deviation very easily by taking square root. First value of x is 20 minus x bar, so 29.25 whole square times f of x is 0.2. So if you simplify this, you should get 17.11. And then we can calculate standard deviation by taking square root, which is square root of 33.19, and this should give you 5.76. So this way we can calculate mean and standard deviation in a slightly different way for discrete data when we are given the probability distribution table. If we use a dice and let's say we represent a random variable x by what number we get, so we can create a table like this for an experiment where we are throwing a dice. Numbers that we can get is 1, 2, 3, 4, 5, 6, and the probability of each number is 1 by 6, so that the total is 1. You can notice that all these probabilities are same. So when all the probabilities are same, this type of probability distribution is called uniform probability distribution. Suppose three students from the class, Brandon, Kelly, and Nicole, they go for an interview, and suppose our random variable x is the student is successful in the interview. So if you have to list all possible outcomes, let's say we represent success by yes and failure by no. If we have to list everything, either all three are yes, all three are successful, or we have yes, yes, no, or yes, no, yes, or yes, no, no. So I have written first everything starting with yes, and then we can repeat everything with no. So these are all possible outcomes. There's no other possibility. How to know like how many outcomes are possible? For example, in this case we have 8. We have 3 candidates and there are 2 outcomes. There are 8 possible things. How do we know that? So generally there is a calculation for that. Total number of outcomes 2 to the power of 3, which in this case is 8. Now this 3 is the sample size. So in this case, like 3 students went for interview, so sample size is 3. And this 2 comes from the outcomes, yes or no. So one thing to note is, in binomial distribution, the word bi means 2. Binomial distribution can be applied when the number of possible outcomes is 2. So yes, no, good, bad, acceptable, not acceptable. In manufacturing, some items when they go for inspection, they may either be accepted or rejected based on if they have any defect, they may be rejected. So in all those situations where we have 2 outcomes, we can make use of binomial distribution. So this example again is example of binomial distribution. Now suppose I want to find out what is the probability that x equals 2. So x equals 2 means exactly 2 students are successful in the interview. Now to find that, I need to figure out of all these 8 outcomes, situations where exactly 2 are y's or yes. So you can see one is this, you have 2 y's, exactly 2 y's. Another one is here, and you have one more which is here. So there are 3 outcomes where you have exactly 2 y, and the total number of outcomes is 8. So we can say the probability of getting 2 students successful is 3 by 8. Let's take another example. So instead of 3 students, let's say there's a class of 46 students. So sample size is 46 and all of them go for an interview. And we want to find out what should be probability of 2 candidates being successful. So I showed you the procedure in the first example, like applying binomial situation and how to find a probability. So what we did was we listed all possible outcomes and then identified which ones are having a specific value like x equals 2, and then we got the probability. So if we try to apply that to example 2, so in the first case total number of outcomes was 8. Let's see how many outcomes are possible here. So 2 outcomes still, yes, no, either a student gets accepted or rejected. So 2 to the power of the sample size, which is 46. So if you calculate, you will get a value like this. So almost like more than 70 trillion different outcomes are possible. It's not feasible to list all of them because it will be very time consuming and also confusing and also unnecessary. So this method of listing everything, although it is very easy to understand, but when n becomes higher, it becomes impractical to use this kind of approach to find a probability. So that's where binomial distribution formula comes handy. So instead of working harder, we can work smarter using binomial distribution. But before we solve this, let me go through some definitions. There is a symbol like this in statistics which is called factorial. Now the key thing here, if you look back, we identified 3 situations favoring a condition like 2 y's. To figure out like how many ways something can occur, so there is a formula like this. We can use a combination calculation. This is called like 3C2. This is written as 3 factorial divided by 2 and then 3 minus 2 factorial. Now to calculate 3 factorial, it's very simple. Start with 3, subtract, keep on subtracting 1 and multiplying till you reach 1. So 3 and then times 2 times 1. So stop there. So this gives you 6. Now 2 factorial is 2 and 3 minus 2 factorial is 1. So 6 by 2 is 3. Now if you have 5 factorial, you can start with 5, 4, 3, 2 and 1. And this will give you 120. And by definition, 0 factorial is 1. So meaning of this 3 is, this 3 tells us there are 3 ways you can get 2 yes. So this 2 represents 2 yes, the way we defined random variable x. So x equals 2 means 2 yes out of 3. So how many ways you can get 2 yes out of 3? So this calculation tells us there are 3 ways. So this helps us to avoid a situation where we have to list everything and then figure out how many ways, how many situations we have 2 yes. So instead of that, if we use this calculation 3C2, and this tells us that number is 3. So this makes our life easier because now what we can do is, in example 2, we can actually find out first of all in how many ways you can get exactly 2 yes out of 46. So 46 C2. So first we have to find this out. So this will be the new numerator. So you have 46 factorial, 2 factorial, 46 minus 2. Now if you simplify, so this probability becomes 1035 divided by 2 to the power of 46. It's a very small number, but at least we can calculate. For combination, general formula is NCX is equal to NC0. How many ways you can get 0 out of n is same as how many ways you can get n out of n, and the answer is always 1. Similarly, how many ways you can get 1 out of n is same as how many ways you can get n minus 1 out of n is equal to n. So to find probability of x equals some value x, you can use ncx times p to the power of x times 1 minus p to the power of n minus x. So if you use example 1, sample of size 3, and probability is half, 50%. If we are interested in x equals 2, if we replace the values in the formula, you get, so if you simplify, you get 3c2 we calculated earlier is 3 times, this is half and this is also half square and half, so it becomes half to the power of 3, which is 3 by 8. You can also use Excel function to do this calculation. So you start by typing equals. So for any function we start by equal sign and then you write down binom for binomial, dist for distribution. The first number you should put is x and then you should put n and then p, probability, and in this case you should put false. So for cumulative you should put false. So 3 by 8 is the answer. This false we use because this is not a cumulative calculation. We are calculating probability of x exactly equal to 2. So this is false. But if we are using less than equal to or greater than equal to, then we cannot use false. We should use true. So I'll give some examples of that also. Same situation. Still n is 3, p is half. So x is less than equal to 2. So if we are calculating this, so this is a cumulative calculation. So you calculate individually and then accumulate. But an easier way will be to use this function. So x is 2, n is still 3 and 0.5, but instead of false now we have true. So instead of calculating 3 times separately, adding them, if you put true here, you get the answer very quickly. One thing you have to remember is if you are using Excel, then Excel is made for this type of format like x less than equal to 2. If it is greater than equal to, then you have to do something different. So for example, if x is greater than equal to 2, so this means probability of x equals 2 plus probability of x equals 3. Now x cannot be more than 3 because like if 3 students go for interview, you cannot have like 4 people getting selected. So maximum number of people who can get selected is 3. So x will be maximum 3. But we also know that all the probabilities like probability of x equals 0 plus x equals 1, x equals 2, 3, so all put together is 1. So you can say 1 minus probability of x less than equal to. So whatever number you have 2 here, you put 1 less. So this is what you will calculate. So you can enter in Excel equals 1 minus, another example. Suppose now your n is 10 and p is 0.8. So what is the probability of x greater than equal to 5? So this you can write as 1 minus probability of x less than equal to, because this is 5, now you have to put 4. And then your function will look like this. Let me also write down some properties of binomial distribution. I wrote the formula earlier, let me repeat. And for binomial distribution, mean or expected value is given by n times p. So simply multiply n and p, you get the average or mean or the expected value. Variance, which is sigma square, is given by n times p times 1 minus p. And standard deviation, which is sigma, is given by square root of n times p times 1 minus p. Suppose n equals 10 and p equals 0.3, and we want probability of x equals 3. So using the formula you can write, now if you simplify 10c3, so 10c3 means in how many ways you can get x3 out of 10 situations. So this is 10 factorial divided by 3 factorial and then 10 minus 3 factorial. There are 120 different ways you can get 3 out of 10. So this becomes 120 times 0.3 to the power of 3, and this is 0.7 to the power of 7. If you simplify you get 0.267. If you are using binomial function, so x is 3, n is 10.3, and false because we are calculating at equals 3, not less than equals or greater than equal to. If you want to calculate probability of, let's say x greater than equal to 3, so this is 1 minus probability of x less than equal to 2. So if you put this, you should get 0.617. So this is a game where there is a chip which is dropped from one of the slots, and these dots you see are the pins. So when the chip falls down, it will hit one of the pins, and obviously it will either turn left or right. So hitting a pin is an experiment, and the outcome will be either a left turn or right turn. So this is a binomial experiment because the outcomes are only two, left turn or right turn at each stage. Question is, for each of the three middle slots at the top of the board, 4, 5 and 6, find the probability that the chip starting in each slot can win $10,000. So what is the chance that, let's say, something starting at slot 5, what is the chance of dropping in $10,000 win? In a binomial distribution, we need to first figure out what is n, like how many experiments. So if a chip has to start from slot number 5, you have to see how many pins it will encounter on the way. If you count like how many rows of pins are there, that will become n. When they start here, they have to encounter that many pins. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n becomes 12. So suppose you start at slot number 5, and let's define a random variable x as, so one can define a random variable as a left turn or right turn, it does not matter. But once you define it as a left turn, you have to stick with that definition. If you define it as a right turn, obviously you have to stick with that definition. Now n in this example is 12 because it has to go through 12 pins. And probability of turning left, because it can either turn left or right, is 0.5. So P equals 0.5. What we need to figure out is, starting from slot 5, how many left turns are needed for a chip to go to win 10,000. So suppose it starts here and takes a left turn. So 1, 2, 3, 4, 5, 6, and then all the remaining, if they are on the right, it will reach 10,000. If we find probability of x equals 6, like 6 left turns. Now these 6 left turns can be in so many different ways. It can be left, right, like alternate left and right, or it could be all left, 6 left first and then all 6 right, or it could be all 6 right first and then left. So there could be so many different combinations. We don't have to worry about that because binomial distribution takes care of that. So now we can find the probability. So in this formula, this thing is, and then once you calculate this, you'll get the probability of winning $10,000 starting from slot number 5. So there is a probability of catching fish which is 0.8 or 80%, and then 3 days next week. When you read this type of problem, although it is not indicated whether it is a binomial or Poisson or hypergeometric, what is given is n and p. So in these situations, so n and p are the parameters of binomial distribution. So let's say you have a sample of 10 laptops in this company, and these 10 laptops go for inspection, and X denotes how many of those laptops are defectives. So your X can take values like 0, like none of the laptops are defective, and X can go up to 10. So obviously you cannot have 11 laptops defective out of a sample of 10. So this situation is basically modeled using binomial distribution, and the parameters of binomial distribution are n and p. N is the sample size and p is the probability of success. Now there is another term called defects. So again, if you have 10 laptops that go for inspection, and instead of defectives, now they are looking at defects. If X denotes number of defects, values that X can take will be, and in fact number of defects can be more than 10 also. So there can be one laptop itself with more than 10 defects. So there may be a scratch on the screen, a key is broken on the keyboard, or there is some other damage, or some problem with the battery, some problem with the software, or some problem with the button switching it on. So one laptop can have more than 10 problems. So obviously with 10 laptops, we do not know the upper limit of how many defects one can get. So when you have these type of situation where you are looking at defects and not defectives, so this can be modeled using Poisson distribution. And Poisson distribution has only one parameter, which is mu. So this mu is actually some type of average. So I'll explain that. Now defects is just one example. You can have situations where you may be looking at errors, like mistakes in filling a purchase order form and so on. So all those situations can be modeled using Poisson distribution. So E is a constant and mu, as you know, is the parameter. Now for Poisson distribution, mean is given by, so no calculation for variance is needed in case of Poisson distribution because it is same as mu. Now you can also use Excel function just like we use for binomial. It says that airline passengers arrive randomly and independently at a passenger screening facility at a major international airport. The mean arrival rate, so this is the key. So mean arrival rate is mu, so this is 10 passengers per minute. Compute probability of no arrival in 1 minute period. The only one thing you have to be careful about while doing Poisson distribution problem is sometimes you are given this mu, like 10 passengers per minute, and A and B, they are asking for a probability with same time period, like 1 minute period. But C, you'll notice it is asking about 15-second period. So no arrival in 15-second period. That's where you have to be careful. Your mu should be in terms of, so per 15 seconds. So obviously this number will be different now. It cannot be 10. So if 10 passengers arrive per minute or per 60 seconds, then obviously in 15 seconds you'll have 1/4 of that. 10 divided by 4, So you should use 2.5 and not 10. Now one example of cumulative situation where you have less than equal to or greater than equal to. So let's look at D. Compute probability of at least one arrival. So we have seen binomial, we have seen Poisson. There's something common about these two distributions. So trials are independent, like for example in binomial when you toss a coin and suppose you get head. So next time you toss a coin, it hardly matters what happened in the past. So if first time you get head and next time the question mark, so coin is not going to remember like first time I got head and next time maybe I should get tail or something. So trials are independent. It hardly matters what happened earlier. It does not know or there is no memory associated with what will happen next. So even if somebody got like 5 times continuous hits, so that does not mean the sixth one is more likely to be a tail. So it can still be head because it does not remember what happened in the past. So trials are independent and also probability of success remains same from trial to trial. So this next one still probability is half of getting head or tail. So probability remains half if you toss a coin for each trial. It does not change. Hypergeometric, in this case trials are not independent. So it does matter what happened in the past. So let me take one example. So suppose you have a pack of cards. There are 52 cards. You want to take out one card out of 52. So what is the chance that you will get an ace? The chance or probability of getting an ace is 4 divided by 52. Suppose the outcome was that you actually got an ace. What is the chance of getting ace again? So it will be 3 divided by 51. Now if you did not get ace the first time, then the second probability could be maybe 4 divided by 51. You can see that trials are not independent. First and second trial, you can see second trial depends on what happens in the first trial. And you can also see probability changes from trial to trial. So again, suppose you have black cards. So half of the cards are black. Now suppose X we denote as, and suppose we want to withdraw 4 cards. And you want to find out what is the probability that you get one black card out of 4. Now to do these calculations, I am going to write a simple format. In the denominator, find all combinations, all possible ways you can get 4 cards out of 52. To find that, we can write 52C4. So this will give us all possible ways we can get 4 cards out of 52. In the numerator, we make room for 2 situations. First one, let's say this is for black, and second one is for red. So we are interested in getting exactly one card black when 4 cards are drawn. So out of 26, how many ways we can get 1? Remaining should come from red. So out of 26, how many ways you can get 3 red cards? So notice that 26 plus 26 is 52 and 1 plus 3 is 4. there were actually 2 good batteries and 2 bad batteries, and somebody by mistake has mixed them, and it is difficult to figure out which ones are good and bad. So suppose we define random variable x as number of good batteries. So if you select 2 batteries out of 4, what is the probability that both of them will be good? So to find this probability, again we make that structure, total 4 batteries. We are selecting only 2. Now suppose this part we represent good and this with bad. So there are 2 good batteries and 2 bad batteries. For x to be 2, both of these should come from good batteries and none from the bad. How many ways you can get 2 out of 2? There is only one way. How many ways you can get 0 out of 2? There is only one way. How many ways you can get 2 out of 4? So if you simplify that, you should get 6. So the probability is 1 by 6. There are 15 restaurants in which this person can take dinner. The only thing is, if the price is more than $50, then he will end up paying from the pocket. If it is less than equal to $50, then the company is going to reimburse. Question is, what is the probability that none of the meals will exceed the cost covered by the company? So 15 restaurants are broken up into 2. So 5 restaurants where dinner price is more than $50 and 10 restaurants it's less than $50. So suppose we define a random variable x such that, so in terms of probability, what is the chance that x is 0? So we make that structure again. So out of 15 restaurants, and note that this person has to eat dinners on 3 occasions. So how many ways one can choose 3 out of 15? So that's the denominator. So let's say this one represents less than equal to $50. That money will be reimbursed by the company, and this is greater than $50, will not be reimbursed. So less than equal to 50, there are 10 restaurants. Greater than 50, there are 5. What is the probability that none of the meals will exceed the cost covered by your company? So none of the meals will exceed cost means actually this should be 3. That all 3 restaurants price is less than equal to $50. Now all the 3 should come from here and none from this.